In this lesson, we will learn about sum and difference formulas of trigonometric ratios. Sum and difference formulas of trigonometric ratios. We will begin with the sine. So, sum formula is like sine of a plus b is equal to sine a times cos b plus cos a times sine b. And the difference formula is sine a minus b is sin a cos b minus cos a sin b. So as you can notice, in both the sum formula and the difference formula, we have the same terms, but the sign changes according to the sign in the formula on the left hand side. So if it is plus, you will have a plus here. If it's a minus, you will have a minus. So this can be simplified as sine of a plus or minus b is sine of sin a cos b plus or minus cos a sin b. So in sine, the sign on the left side and the sign on the right side will always be the same. Whereas in terms of cos of a plus b is equal to cos a cos b minus sin a sin b. You will notice two different things here, the plus on the left hand side and the minus on the right hand side, and also the terms here, like when the cos sum formula, you will have both the terms as cos a cos b, and then the next term is sin a sin b, whereas in sin of a plus b you will have the first term as sin and the next term as cos, and the second one here is like starts with cos and ends with sin, whereas in cos it's like cos and sin. Similarly, cos of a minus b is equal to cos a cos b plus sin a sin b. It's the same formula again, but the signs have been reversed. Now let's look at the third ratio, which is tan of a plus b. Tan a plus b is tan a plus tan b by 1 minus tan a times tan b. So the numerator will have the same sign as the sign on the left hand side, but on the denominator you will have a minus. And as you can see, on the numerator it is the sum of the individual tangents like tan A and plus tan B, and on the denominator you have 1 minus the product of tan A and tan B. Similarly, for tan of A minus B, you have tan A minus tan B by 1 plus tan A times tan B. So similar to the above formula, on the left hand side you have a minus, and on the right hand side on the numerator will have a minus, but on the denominator you will have a reverse sign, which is plus, and the numerator will have the difference of the two tangents, and on the denominator you will have 1 plus the product of the two tangents. So these are the six sum and difference formulas of trigonometry ratios that you would need to remember to solve some problems in the next lessons. Now let us work through some problems. Calculate sine of 105 degrees. So how do you do this? So if you break this into the standard trigonometric ratios that we have, 60 plus 45, we can 60 plus 45 is 105. So now if you look at this, it is in the form of sine of a plus b, right, where a is 60, b is 45, and we know from our previous lecture, sine of a plus b is sine a cos B plus cos A sin B. So applying that formula, sin of 60 plus 45 is sin 60 times cos 45 plus cos 60 times sin 45. So that is equal to, we know sin 60 is root 3 by 2 times cos 45 is 1 by root 2 plus cos 60 is 1 by 2 times sin 45 is 1 by root 2. So that is equal to root 3 by 2 root 2 plus 1 by 2 root 2, which is equal to root 3 plus 1. So sine 105 is equal to root 3 plus 1 by 2 root 2. We can further simplify this if you like by multiplying the numerator and denominator by root 2. So what would that make it? So root 3 plus 1 by root 2 times 2 root 2, which is equal to root 6 plus root 2 by 4. So sine 105 is equal to root 6 plus root 2 by 4. Now let's work on another problem. Let's calculate cos 105 degrees. So there are two ways you can calculate this using the sum formula and say cos of 60 plus 45, or you can use a difference formula and say cos 135 minus 30. So I will solve this using the difference formula just for illustration sake. So we know that cos A minus B is equal to cos A times cos B plus sin A times sin B. So if I substitute 135 and 30 for A and B, I'm gonna be getting this 135 minus 30 is cos 135 times cos 30 plus sin 135 times sin 30. So if you have to further simplify it, you know cos 135 is cos 90 plus 45 and times cos 30 plus sin 90 plus 45 times sin 30. So if you remember from our previous lessons, the coordinate plane, we know that all study trigonometry carefully. So we know that this is 90 and we are looking at 90 plus theta, so which is in the second quadrant, and in the second quadrant we know that sine and cosecant are positive, and here we are asking to calculate cos, which would be the sign would be negative, and we know that 90 is a odd number of right angle triangles, so we have to change it to cos into sine, so it is sine 45 degrees, right? Similarly it is cos 30 plus. So now let's calculate sine 90 plus 45. So sine 90 plus 45, if you observe, it's 90 plus theta. In second quadrant, sine is positive. And because 90 has odd number of right angles, we have to change it into its co-ratio, which is cosine. So it is cos and the sine is positive and it will remain as cos 45 times sine 30. Right? So now further simplify, we know sine 45 is 1 by root 2, cos 30 is root 3 by 2 plus cos 45 is 1 by root 2 times sine 30 is 1 by 2. So as you can observe, we will be having minus 3 root 3 plus 1 by 2 root 2. Again multiplying numerator and denominator by root 2, we will have minus root 6 plus root 2 by 4. So cos 105 degrees is minus root 6 plus root 2 by 4. Now let's work on the third problem, which is calculating tan 75 degrees. So tan 75 degrees can be expressed as tan of 30 plus 45. So which is in the form of tan A or tan of A plus B, which is equal to tan A plus tan B by 1 minus tan A times tan B. This is our identity from previous lecture. So now substituting A is 30 and B as 45, we end up with tan 30 plus 45 is equal to tan 30 plus tan 45 by 1 minus tan 30 times tan 45. Now let's try to calculate this. So this can be written as tan 30 we know is 1 by root 3 plus tan 45 is 1 by 1 minus 1 by root 3 times 1, which is equal to taking LCM and doing the math on the numerator, we will have 1 plus root 3 by root 3 divided by same thing here, taking the LCM and the math on the denominator, root 3 minus 1 by root 3, which is equal to 1 plus root 3 by root 3 times root 3 by root 3 minus 1. So this would be 1 plus root 3 by root 3 minus 1. We can multiply the numerator and denominator by root 3 plus 1, which will make it 1 plus root 3 by root 3 minus 1 times root 3 plus 1 by root 3 plus 1, which is equal to 1 plus root 3 whole square by root 3 square minus 1 square, because a minus b times a plus b is a square minus b square, and over here a plus b times a plus b is a plus b whole square, which can be further simplified as 1 square is 1, root 3 square is 3, plus 2ab is 2 root 3 by root 3 square is 3 minus 1, which is equal to 4 plus 2 root 3 by 2, and you can do the math here, 2 answers, so it will be equal to 2 plus root 3. So tan 75 is nothing but 2 plus root 3. In this way, we have applied the sum formula of tan to calculate 75 from the angles 30 and 45. Now let us work on another problem. Simplify the equation sine of a plus b times sine a minus b in terms of only sine function. So let's work on this. So we know from our previous identities that sine of a plus b is sine a cos b plus cos a sine b, and that times, and again we know from our previous identity sine a minus b is sine a cos b minus cos a sine b. So if you observe this, this is in the form of a plus b times a minus b, so which is a square minus b square. So it becomes sine square a cos square b minus cos square a sine square b. The problem asks us to simplify sine of a plus b times sine of a minus b in terms of sine function. So we should convert cos into sine. So let's do that. We know from our trigonometric ratio identity, the basic identity, that sine square theta plus cos square theta is 1. So cos square theta is 1 minus sine square theta minus, again here, 1 minus sine square A times sine square B. So let's simplify this. So sine square A times 1 is sine square A minus sine square A sine square B minus sine square B minus sine square A times sine square B. So this is equal to sine square A minus sine square A times sine square B minus sine square B and plus sine square A times sine square B. So sine square A and then it cancels out, and then we are left with sine square A minus sine square B. So if we were asked to simplify this equation in terms of sine, we will do this approach, and we'll end up with sine square A and minus sine square B. With the Let's ask this problem a little differently and say simplify the equation to in terms of cos. So we could do that, see, as simple as, again, from using a basic trigonometric identity, we know that sine square A is nothing but 1 minus cos square A minus sine square B is nothing but 1 minus cos square B, which turns out to be 1 minus cos square A minus 1 plus cos square B. So minus 1 cancels out, so it ends up being cos square B minus cos square A. So the same equation can be expressed in terms of sine or cos using this approach.